Hello, this is Tove Nødbeck from Nanopower Semiconductor, and I'm standing here today in front of this beautiful autofocus landscape in order to present to you the nPZero configurator. And this is a desktop tool that we provide in order to help you evaluate, develop and test applications based on the nPZero power saving IC. Throughout this video, I'll break down the various elements of the tool and show how to use them effectively. So for this, let's get a bit closer. Here you can see the main interface of the nPZero configurator. The main interface is split into separate views, most of which are organized horizontally across the screen. Each view can be individually resized by dragging this line in between the views. You can also show and hide individual views by using the view menu or by using the associated shortcut. Any change you make in the configurator can be stored into a workspace. From the file menu you can load or save workspaces. You can also reset the application back to the default settings using the Reset Workspace option. And you can look at recently loaded or saved workspaces using the Recent Workspaces menu. Starting from the left, we'll take a closer look at the register view, which provides an interactive representation of all the registers available in the nPZero IC. This information is the same as you can find in the nPZero datasheet, but here it's broken out in a more interactive way. On the left side, you have a column called Address, which lists the unique 8-bit address for each of these registers. And that's the same address that you would use if you want to access the register over the I2C bus. The second column contains the name of each register. The third column provides the value in hexadecimal format. And then the fourth column includes all the fields for this particular register. Here you can hold your mouse over any of these fields, which will provide a pop-up with additional information, such as the name of the field, whether the field can be read from or written to or both, what the field does, and also a list of all the possible values that this field can contain. For multi-bit fields it will be a longer list showing what each value signifies, and some fields will simply be numeric and have a numerical range rather than specific options. In order to change these values you can simply click on any of them. 1-bit fields will just toggle when you click them. Multi-bit fields will provide a list of options where you can select which one you want to set. And numeric fields will provide you a slider and a text box allowing you to set that field specifically. It's also possible to set the value of the entire register by changing the value in the value column. By using the 0x prefix you can set the value in hexadecimal format. If you don't use any prefix, you can set the value in numeric format. And if you use the B prefix, you can set the value in binary format. Any value that is changed from the default will get a different color, so you can easily see which of the registers have been changed from the default and which have not. And once you're happy with all these register configurations, you can then save the configuration and save the workspace as described before. Not everyone will have the time and inclination to really understand what every bit and every byte in the nPZero configuration can actually do. So for that reason we provide this configuration field, which provides a higher level and more intuitive interface to control how the nPZero behaves. So here all the functionalities are broken out in different graphical elements. Each control will have its own description. Most of these will have tooltips giving more context about what this particular function is doing. For things like time, there will be conversions, so instead of setting time as some cryptic hex value, you can just provide it directly in minutes or seconds. The configuration view will also try to hide configurations that are not currently available. So for instance, if I don't enable the internal ADC channel as a trigger, then I won't get access to the controls to set the actual trigger level. Once I disable that again, that control will be hidden. The same goes for the peripherals. So the nPZero G1 device, it supports 4 different peripherals or sensors. Each of them have a separate sort of independent control. For the time being, they're all disabled, so you can't really see anything here. But once you enable one of these, then you will see the configuration for that particular peripheral show up. I'm not going into the details of all the fields here now, that will come in a later video. But essentially, you can set the peripheral as you like. All the changes you make here will also be reflected in the register view, so everything is synchronized between the two views. You can save and load peripheral presets. So rather than just saving the entire workspace, if you get the sensor working as you like, you can save that to a preset. You can also load presets for various sensors that we have tested in-house. So for instance, the two sensors provided with the nPZero development kit, they will be provided here. That is the LIS2DW accelerometer and also the AS6212 temperature sensor. So if you want to set up your nPZero device to work with one of these sensors, you can do that quite easily from here. Last but not least, we're going to take a look at the generated code view. And what this view provides is a code generator that takes the configuration that you've established in the previous two views and condenses that into a code snippet that will be compliant with the nPZero API, which is the official driver from Nanopower for using the nPZero device. And essentially all of these different configuration parameters will be condensed into these structures. The code is relatively human readable, so you can sort of see the same changes that you made here reflected in these structs. This is all synchronized live, so any changes you make here will be live updated in the code snippet. And this default template provides a full main file that essentially initializes the host MCU. It initializes the nPZero driver. It reads the status registers of our device, configures the device, and logs the configuration for debugging purposes. And then it calls this go to sleep function, which will essentially instruct the nPZero device to take over control of the system and disable the MCU completely. Essentially, this while loop should never be reached, but for debugging purposes, if there is some issue with the I2C communication, it's useful to have this loop in place. And once you're happy with the configuration and you want to deploy this on your target MCU, you can then save this to a file. There are some different templates available. At the moment, STM32 and the nRF52 platform for Nordic are officially supported. We're also supporting a basic reg map option, which simply condenses the entire configuration into a register map. So the left column here is the address and the right column is the value. And the advantage of the register map is that if you have an MCU that is constrained in memory, you can support the nPZero with very little memory overhead. So you don't need to use the full API. You can simply write these values over the I2C bus and our device will be configured correctly. So the drawback is that the code is less readable, but assuming you're using the nPZero GUI to set up the configuration, then that might not be a big issue. Okay, I hope that gave you a good overview of the nPZero configurator and how you can use this tool in your own projects. If you're interested in downloading the tool or getting in touch with us, there will be links provided in the description below showing you where to go to do this. Also, there will be more videos coming out in the future, so please do subscribe if you're interested in updates whenever we release another video. Thank you very much.